All right, folks, time for our last set of Module 4 notes. I know everyone's going to be very disappointed, but this should be it. We're going to wrap up with Lesson 4-33. Good thing we didn't do every single one of those. Post-Module 4 review. So we finished Module 4, finally. It's a nice long one. Time to review some of the things that we've learned. Now, I want to try to keep these notes down to one page, so we're going to smash some things together. We're going to kind of skim past some things, because again, Module 4, this part of it really does build on itself, so hopefully you'll see what I mean as we go through. Our Roman numeral here, 10, 20, 30, 31, 32, 33. So Lesson 33. Time to put it all together and review what we have learned. X, 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 I, I, I. I, I, I. All right, let's start with A. We're going to talk about lessons 413 and 15. So if you want more information on this, you're going to look at the notes for 4-13 and 4-15. Again, I'm going to try to just kind of condense a little bit. These two lessons deal with multiplying fractions. Now, multiplying fractions, very basic. You are going to multiply straight across the top and straight across the bottom. So if I give you 5/8 times 8/15, I could just go ahead and multiply straight across. 5 times 8 would be 40. 8 times 50 would be 120. So that's kind of big. I don't really want to do that. I can, and I would end up doing some long division at the end, and that's fine. So if that's what you're comfortable with, straight across the top, straight across the bottom. But I'm going to do a little bit of cleanup as I go. I am going to simplify a bit as I go. So I'm going to look at this. 5/8 times 8/15, not changing anything yet. But I am going to attempt to cross cancel. I am going to look at the 8 and the 8. And I'm going to treat it like a fraction just by itself. 8/8. Well, if I have 8/8, that's pretty easy to simplify. It's just 1. Because 8 divided by 8 divided by 8, just 1/1. So when that's the case, 8 divided by 8 is 1. 8 divided by 8 is 1. Again, what I'm doing here is I'm looking for a common factor. I'm looking for something I can evenly divide this and this by. Well, they can both be divided by 8. Now, 5 and 15 won't work quite the same way. They're not the same. But I can look at 5 and 15, find the greatest common factor. I know that 2 won't go into them. 3 will go into this one, but it won't go there. 5, however, will go into both. Divide this by 5, you get 1. Divide this by 5, you get 3. Again, pretend 5/15. How would you simplify that? 1/3. Now with all these ones, multiplying straight across the top is super easy. 1 times 1. Multiplying straight across the bottom, similarly simple. 1 times 3. So when I put it all together, my final answer for this, my final product, is 1/3. Now this is just one example. We went super fast through this, so go back and look at the lessons if you're not remembering, especially with the cross-canceling. It can be done without cross-canceling, but it takes longer. It takes longer. Now for part B, we're going to expand on that, because in lesson 4-16, we solved some word problems with fraction multiplication. Word problems with fraction multiplication. There we go. Oops, make sure it stays on the screen. Word problems with fraction multiplication. So I'm not going to write out a full word problem. I don't think any of you are interested in that right now. But I will give you a phrase, something pretty common that you might see. 5/7 of 14, I don't know, 14 walnuts, 14 staplers. Doesn't really matter. With a real word problem, it would. But the big thing I want you to remember here is that when you see a fraction of a whole number, that means a fraction times the whole number. And I could write 14 here, but I'm going to kind of take a shortcut. I know that any whole number can be turned into a fraction simply by writing it over 1. If I convert my of to multiplication, I convert my 14 to 14 over 1, suddenly I have something that looks a lot like what we had up here. I can do a little bit of cross-canceling again. 7 and 14, I can divide them both by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. Now 5 and 1, not going to do anything. So I'll just go ahead and multiply across. Just in the interest of time and space, which sounds very dramatic, we'll go ahead and just do that here. 5 times 2 is 10. 1 times 1 is 1. 10 over 1 is 10. Again, anytime I have a fraction with something over 1, it's just another way of showing that particular whole number. Whatever the numerator is, that's the whole number. Now, we were not dealing just with fractions, although if you like that, it does come into play here. We also did some work with decimal and fraction multiplication. Decimal and fraction multiplication. I don't know why I feel like I have to sound out every little bit of that. Sorry. Decimal and fraction multiplication. Now for this we are going to have a couple quick notes. Really, that being said, even just one. Whatever you end up with, a decimal times a fraction times a decimal, you need to change one or more. Usually for us it's just going to be 1, but if you needed to change more, you could. Change one or more factors. Change one or more factors so that all, and I am really going to emphasize this, because the best way to do this is to make sure that all of your factors, all of them are in the same form. Okay. Now I'll finish shading in my letters later. You know how much I enjoy that. Factors so that all factors are fractions or decimals. You get to pick what you feel most comfortable with. If you feel good about multiplying decimals together, then you're going to want to change any fractions you see into decimals. I will say you want to be careful with that one because sometimes fractions don't want to turn into decimals and then you end up with really weird stuff. But that option is there. Most of what we're going to be doing is turning everything into fractions because honestly I think that's a little easier. But you need to pick the strategy that works for you. Let's take a look at one example. Let's take a look at one example. Let's say we have 32 hundredths times 5/8. And I kind of wish I'd written it the other way because a lot of times in word problems you will see some fraction 5/8 of 32 hundredths. Remember, commutative property of multiplication tells us we can change the order. It doesn't really matter. But I should have done it the other way. That's what they'll probably look like most often. We'll go ahead and finish though. Originally I started with the decimal first because looking at these two, I can try to turn 5/8 into a decimal, but I'm going to have to do some long division. It's going to be probably like 3 digits long. I don't really want to mess with that. Turning this into a fraction is actually a lot easier because all you have to do is read it. 32 hundredths. 32 hundredths. Now I could actually even simplify this, but I won't bother right now. I'm just going to go through with my multiplication. 32 hundredths times 5/8. Now I'm going to scoot this over a little bit, and I am going to rewrite the 32 hundredths times 5/8. I think most of you can probably guess what's coming. I am going to cross cancel. 32 and 8 have a common factor. I could divide them both by 2, I could divide them both by 4, but really, I can divide them both by 8. I'm going to pick the greatest common factor, the biggest one, because then I'll have to do less canceling. 32 divided by 8 is 4. 8 divided by 8 is 1. 5 and 100 are a little bit easier because I know 5 is going to be the only common factor. 5 divided by 5 is 1. 100 divided by 5 is 20. And I love when I get something like this, 1 over 1, because we know that the answer is just going to be the fraction then. 4 times 1 is 4. 20 times 1 is 20. Now we have to be careful. I've told you if you do this, you don't have to really simplify at the end, and that's a bit of an oversimplification. This was not simplified to start with, so I need to do just a tiny bit more. If I divide the top and the bottom by 4, I end up with my final answer, 1 over 5. 1 over 5. Okay. Again, you may change the decimals into fractions. You can turn the fractions into decimals. You can do whichever you prefer. Since we spent a lot of time with fractions recently, I feel like that's probably the better recommendation, but either works. Whatever you like to do. If these were both decimals, you could use the standard algorithm, multiply them together. Done. Okay. I know the review notes are always a little bit longer, but we're pushing 15 minutes here, so let's go ahead and continue. For 4-25 and 26. So 425 and 426. In these two lessons, we were dividing with a unit fraction, and a whole number. Now we did this two ways because division is not as relaxed as multiplication is. There is no commutative property here. You have to be very aware of the order the numbers are written in. For example, if I give you 5 divided by 1/3, and I'm going to write them a little smaller because we need to save some space for later. 5 divided by 1/3, I told you to multiply the whole number times the denominator. Now again, this only works with unit fractions, fractions that have 1 on the top. 5 times 3 is 15. Okay, so we multiplied, we'll put a little note here, multiply, see there you go, sounding the whole thing out again. Multiply the whole number times the denominator. Okay. Now you're going to do something very similar when the unit fraction comes first. Let's say that instead of 5 divided by 1/3, I had 1/3 divided by 5. So in this first case, I had 5 wholes. I had 5 complete pizzas, and I'm dividing each one into thirds. This time it's the other way around. I have 1/3 of a pizza left, and I'm dividing that into 5 groups. Now the crazy thing is, the tip I gave you was pretty much exactly the same, wasn't it? If you look back at that lesson, I told you to multiply the whole number times the denominator. Well, wait a minute. The answer cannot be 15. It is not 15. If I only have 1/3 of the pizza and then I'm cutting that up into pieces, I'm getting really small. I actually am going to have 1/15. Okay, so how do I know which is which? If I'm basically doing the same thing, multiply the whole number times the denominator, how do I know when I get a whole number? How do I know when I get a fraction? The key here to remember, aside from the whole multiply the whole number times the denominator thing, you end up with what you start with. Now, what I mean by this is you're going to look at the dividend. If the dividend is a whole number, your final result will be a whole number. If the dividend is a fraction, your final result will be a fraction. You're doing the same thing, whole number times denominator, whole number times denominator. But if you started with a whole number, if the whole number was your dividend, if the whole number is in the front, then your answer is going to be a whole number. Because you're taking something big and breaking it up into teeny tiny pieces. But if you start with something teeny tiny and break it into big pieces, 1/3, a fraction divided by 5, this is less than 1, you're going to end up with a fraction over here too. Now, as you get older and you start dividing with larger fractions, they're not all unit fractions, you'll get to see a little bit more why that works. But for right now, you just have to remember whole number times the denominator, end up with what you start with. All right, let's see if we can finish this thing up before we hit the 20-minute mark. We are going to combine lessons 429, 430, and 431 all into one section, because all three of these deal with dividing with decimals. Dividing with decimals. Okay? So let's say I give you 43 and 4/10. 43 and 4/10 divided by 3500. A little bit of thing there. Okay. Now, in the early lessons, we talked about how we could turn these into fractions. You could use the fact that division and fractions are basically the same thing to write the division expression as a fraction. Then we could multiply the top and the bottom by the same thing to come up with an equivalent fraction, to come up with something that's equal to this, but doesn't have decimals anymore. This has 1 decimal place. This has 2. So I'm going to need something with 2 zeros, a 1 with 2 zeros specifically, to clear out decimals above and below. Now if I do that, 43.4, I'm going to move over 1, 2 places. So it moves over past the 4. So 43 and 4/10 times 100 is 43. The decimal moves over 1 spot and a second spot, so I have to put a 0 there. Now the 35 doesn't get that extra 0 because 1, 2 hops stops it at 35. Now from here I could set up the standard algorithm, go ahead and divide, but like we talked about in class, there's actually a way to do all of that in one step. Well, in one algorithm, one format, I guess I should say. Let's go ahead. We'll pretend we didn't do this part. I wanted you to see it one last time, but let's pretend didn't do that. We just took the dividend, put it inside of here, took the divisor, put it out here, and then to simulate, well, I guess you're not simulating, to show that we're multiplying, I'm going to look at the divisor. The divisor dictates, the divisor decides. We're going to look at this little decimal point. This little decimal point desperately wants to get into the hut. So it's going to run over 2 spots. I will erase it. I will put it over here. Now, 35 hundredths is just 35. But as this decimal is running over, I don't know, maybe it's a monster decimal, this decimal inside the hut sees that and freaks out, oh no, and runs the same number of spots. It needs to go the exact same number of places, even if that means I have to add an invisible 0. Some students look at this and think, well, wait, I can just move it over once and I've got a whole number. Yay! True. But remember, we have to multiply the top and the bottom by the same number. You have to multiply it by the same number, the same value, because really what you're doing is multiplying times 1. It's not one of my better ones, but we'll go with that. Okay? So 1, 2 jumps, 1, 2 jumps. I don't know, maybe this guy climbs on the roof too. I figure it'll be safer there. Then we divide as normal. And really, you probably are noticing 4340, 4340. This is exactly what I would have had if I had just done this part. 35 will go into 4 no times. 35 will go into 43 once. 1 times 35 is 35. We'll subtract to find the difference. 13 minus 5 is 8. 3 minus 3 is nothing, so I'll just leave that alone. I will bring down the 4. And I have to be careful. I left a little too much space there, so I've got to be sure that everything's lining up nicely. Graph paper is our friend. 35 is going to go into 84 about twice, because I know that 2 times 35 is 70, and that's pretty close. When I subtract those two, 4 minus 0, 8 minus 7, I get 14. Ugh. Smaller than 35, but double digits. I bring down that invisible 0. And now I have to figure out how many times 35 will go into that. Now I look at the 140 and I see 70 and I'm thinking, wait, 70, 140, 7, 14. This is 2 times that, which means 35 will go in twice as much as this. 4 times 35. Now, if that didn't make sense or you just need to experiment in the margins, please do that. There's nothing wrong with just picking a number, multiplying by 35, and checking to see if it works. 4 times 5 is 20. 4 times 3 is 12, plus the 2 would be 13, 14. So this does work. And thank goodness, because we're out of paper. But you could experiment, you could check over here to see. Now, in this particular case, we got it to work out. Our final answer, 124. This works. Let me say this works especially well when you have smaller numbers, but this works too. Now, as I'm looking at the time, I'm realizing this one took 25 minutes, so I'm going to stop talking. That's one of the longest ones we've ever done. Please, if you have any questions, bring them to class. We'll spend some time on the study guide. We'll get you ready for your test. Ladies and gentlemen, thank you. I will see you next time.